Hi guys, today we're going to go over Honors Chem Chapter 9, Section 3 on limiting reactants and percent yield. So two definitions that we need to know. The limiting reactant is the one that limits how much product you can make. The excess reactant is the one that is not completely used up, you have extra. So excess means there is extra reactant. Okay, and so I have an example for you guys. Here is our equation to make a delicious cheeseburger, 2 buns, plus a meat patty. There's my undo. Plus 2 slices of cheese, 3 pieces of lettuce, 2 slices of tomato, 1 delicious cheeseburger. So that is our equation. That's our analogy equation here. And let's say that we start with all these ingredients. So we want to know, what is the limiting reactant? Well, the steps that we're going to take is we're going to see how many cheeseburgers I can make starting with each of these given values. And the number of cheeseburgers that I can successfully make would be the one that makes the fewest number of burgers. So, for example, 12 buns over 1, we would say that we need 2 buns to make 1 cheeseburger. Okay, now we don't have to write this out for every single one of these, but this is in the chemistry equation how we would solve it. The buns cancel, right? And 12 divided by 2 means I can make 6 cheeseburgers with 12 buns. Okay, so we have to figure out from each of my reactants, how many cheeseburgers can I make? 5 meat patties, 5 meat patties equals 5 cheeseburgers. So I'm just going to write the number of cheeseburgers above each thing since we have a lot more. So this was 6. With 5 meat patties, I can make 5 cheeseburgers with 13 slices of cheese because this particular cheeseburger has 2 slices in each. That means 13 divided by 2 is 6.5 cheeseburgers, which of course we can't make a half cheeseburger. 18 pieces of lettuce. I need 3 for each cheeseburger, so that's 6 cheeseburgers. And then 14 slices of tomato. If I put 2 on each, that means I can make 7. So how many cheeseburgers can I actually make? Well, it's the number that makes the fewest, and that is 5. So because I will run out of meat patties, I can make 5 cheeseburgers is the number that I can make before I run out of my limiting reactant. Okay, 5 cheeseburgers because meat is the limiting reactant. Limiting reactant. And the second question, you guys can try this on your own. How much of each reactant would be left over once I made those 5 cheeseburgers? We're not going to do those types of problems this year. We usually have that as like a bonus question. So you guys can answer that on your own. But basically, you work backwards to figure out how many did you use, how many did you start with, and you'd figure it out that way. So let's look at another example. Why don't you guys try this? So in order to make the perfect s'more, you need 2 graham crackers, 1 marshmallow, and 3 pieces of chocolate to make 1 s'more. If you are starting with this amount of each thing, how many perfect s'mores can you make? You guys figure it out. All right. Suppose you start with 12 graham crackers. That means 6 perfect s'mores. 5 marshmallows, well, that only makes 5 perfect s'mores. And 13 pieces of chocolate. So I need 3 pieces in each. That can only make 4, and then I will run out of chocolate. So the limiting reactant is the one that makes the fewest number of s'mores, and that is my chocolate. I'm just going to put LR for limiting reactant. Chocolate. What would be the limiting reactant? The excess reactants would be, I would have leftover graham crackers and marshmallows. I would have 1 marshmallow and Let's see, if I made 4 s'mores, that would use up 8 graham crackers. I would have 4 graham crackers left over. But my limiting reactant is the chocolate. Okay, so now real chemistry example. Basically what this boils down to is we're doing 2 stoichiometry problems. Okay, so it's nothing new. It's just a stoichiometry problem. But we have 2 given, so I'm going to have to do 2 different calculations, one with 6 moles of HF and one with 4.5 moles of SiO2. And then the limiting reactant is whatever makes the fewest number of moles of product. Okay, since I have 2 products here, we get to decide which product we're going to make. It's not like where I just made 1 s'more before. We have 2 products. So I'm going to choose the SiF4 kind of randomly, mostly because there's just 1 of them being formed. So to solve this, we are going to pick 1 product, SiF4, and using the given numbers, I have 2 of them now, not like the last stoichiometry problems, we just had 1 given. And I'm going to find the number of SiF4 twice, 2 times. The one that makes the smallest amount is my limiting reactant. Okay, so down here, since I'm given moles and I'm just looking for the limiting reactant, I don't need to find grams of SiF4. So I'm just going to do a simple 1-step stoichiometry problem, multiply by the mole ratio, moles of HF to moles of my product, SiF4, moles of SiO2 to SiF4. And again, the one that makes the least is my limiting reactant. That's this guy. Okay, because you can only make 1.5 moles of SiF4, and then I run out of HF, which is hydrofluoric acid. So hydrofluoric acid, HF, therefore, because it makes the smaller number, is my limiting reactant. The one that produces the smallest amount limits the reaction. Therefore, HF is my limiting reactant. Okay, this next sample problem is out of your textbook. So, oops, showing you the answer. I didn't mean to do that. Pretend you didn't see it. So my given in the problem in your book, you can read sample problem G in chapter 9 if you want to read the actual wording of it, but I've just pulled out the given for you. I start with 36 grams of water. Okay, so H2O is 36 grams, and 67 grams of iron. And the question says, if you're starting with those 2 given amounts, how much, sorry, not how much product, but what is the limiting reactant of this? So I have to go from grams of H2O. I have to change it to moles of H2O in order to use the mole ratio. And I'm going to find one of my products. I'm going to choose this one. I'm choosing this product. You'll see why in a second. So moles of H2O to moles of Fe3O4. And I can stop there. And then I have to do grams of iron. Change it to moles of iron, divide by the molar mass. And change that to moles of Fe3O4. And whichever makes the least amount is my limiting reactant. Okay, so I have the calculations down below. Let's see here. Okay, so I started with 36 grams of water. I divided by the molar mass of water, 18.02 right here, and then times the mole ratio, which was 1 of these guys, requires 4 moles of water. So it's a 1-to-4 ratio, and I made 0.449, I should put the units here, moles of Fe3O4. And then when I start with 67 grams of iron over 1, divide by the molar mass of iron this time, and this ratio is 1 to 3 because the coefficient for iron is 3, I get 0.400 moles of Fe3O4. So which one can I actually make? Well, I can only make the smaller amount, and then I will run out of that reactant. So because the smaller amount, 0.4, came from iron, iron is my limiting reactant. Okay, hopefully that makes sense. And then there is a part B to this, and it says what mass of this Fe3O4, which is called black iron oxide. What mass can we make? Well, I can't make this much because I will run out of iron. I can make 0.4 moles, but it said what mass in grams. So basically we're just going to change it from moles to grams. So from that 0.4 moles over 1, I'm going to put moles on the bottom and grams on the top. This is the molar mass. We're just that one last step where we multiply by the molar mass, and this would be how many grams of that black iron oxide I can produce. Okay, and then the last little thing from today, we're not doing this type. You can if you want to try that one. That would be like a bonus question. The last thing is kind of from the lab. So we've already learned this. The theoretical yield is theoretically, in a perfect world, the maximum amount that can be produced. And this is a calculated value. Okay, so the theoretical yield is, you do a stoichiometry problem, you calculate how much you should make. The actual yield is either from a lab, how much did you actually get, or in the question, it'll say you made this amount. That's the actual given amount that you made, okay? So to find the percent yield from that, you guys remember this from the lab, it's the actual yield divided by the theoretical yield times 100. So if I actually made 0.39 and my theoretical yield was 0.40, for example, that would be 0.39 divided by 0.4 times 100, 97.5% in this totally made up example, for example. Okay, so that is percent yield. All right, guys, I'll see you tomorrow. I hope you have a wonderful day. Bye-bye.